Okay, so from the in the two port networks, our main goal is finding the parameters like impedance parameters. So there are four parameters we're going to find. The first one is impedance z parameters, second one is y parameters, third one is hybrid parameters, or I would say ABCD parameters, and the fourth one is h parameters. H means hybrid parameters. ABCD parameters are also called transmission parameters. So these are the four parameters we're going to find in this chapter. So my first goal, I'm going to talk about how to find hybrid parameters. So this block box, I don't know what is in there. It could be elements like resistors, inductors, capacitors, or diodes, transistors, but there is no independent source in that block box. So there can be some dependent sources but not independent sources. But I know V1 I1 and V2 I2. So in this two-port network, we always take I1 is entering, I2 is also entering, V1 the top terminal as positive, V2 top terminal as positive. Okay, so this is common for every circuit. Okay, whenever you see a circuit, sometimes in this block box I might give you some elements like a resistor, inductor, or capacitor, something like this. Okay, so I might give you this element, sometimes I might not give you those elements. Okay, so I don't know what is in there in that block box. How to find impedance parameters? What are the impedance parameters we're going to find? So to find the impedance parameters, these are the equations, two equations. The first equation equal to V1 equal to Z11 I1 plus Z12 I2, and V2 equal to Z21 I1 plus Z22 I2. Okay, so these are the two equations we're going to use to find the impedance parameters. So here Z11, Z12, Z21, Z22 are the impedance parameters. Now if I write them in the matrix format, so here is the matrix format. I have V1, V2 equal to Z11, Z12, Z21 and Z22 equal and times I1 and I2. This is the matrix format. Okay, now to find out Z11 here, let me see. So here if you look at this first equation, how do I get the Z11? If you look at the Z11, can I make this term as 0? So when this term is going to be 0? When I2 equal to 0. When I2 equal to 0, so when I2 equal to 0, Z11 equal to V1 over I1 when I2 equal to 0. So this Z11 is called open circuit. Why it is open circuit? Because I2 equal to 0. Only current is going to be 0 in open circuit. Open circuit input impedance. Okay, so Z11 is called open circuit input impedance. The next one is Z12 equal to, if you look at here, I want to find this term, so this term must be 0. Z12 equal to V1 over I2 when I1 equal to 0. This is called open. So Z12 equal to V1 over I2 when I1 equal to 0. This is called open circuit. Z parameters are always open circuit because either I2 equal to 0, I1 equal to 0. So open circuit transfer impedance from port 1 to port 2. Okay, so Z12 is open circuit transfer impedance from port 1 to port 2. That's called Z12. Okay, and you can see Z12 is nothing but always the first letter is going to be in the numerator and the second letter is going to be in the denominator. Okay, so z12 is z is nothing but impedance, which is z is nothing but impedance, which is nothing but v over I. So if you want z11, it's v1 over I1, z22 v2 over I2. Okay. Okay, the next one is z21. You can clearly see, so it is 2 1, so the numerator must be v2 and denominator must be I1. So other independent quantity is when I2 equal to 0. This is called open circuit transfer impedance from port 2 to port 1. Okay, and the last one is z22, which is v2 over I2 when I1 equal to 0. Okay, this is open circuit output impedance. These are the z parameters. Now, so there are two important things. One is if z11 equal to z22, then that circuit is called symmetrical network. Then that network, I sometimes say network or circuit, you can call a network you can call a circuit as a network, but you cannot call a network as a circuit. So yeah, then that network is called symmetrical network. That network is called symmetrical network. If z12 equal to z21, then that network is called reciprocal network. Okay, one is symmetrical network if z11 equal to z22, or if z12 equal to z21, that's called reciprocal network. Okay. Here z11 and z22 are called driving point impedance, and z21 and z12 are called transfer impedance. Okay, so the next video I'm going to start solving an example finding these z parameters. Thank you.